Hello, everyone. Thanks for joining for this session using LLMs in Python. My name's Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. And while we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on the chat. We'll be dropping helpful links and checking for questions for our presenter to answer live. This session is being recorded. It will be available to view on demand within 24 to 48 hours right here on the Microsoft Reactor YouTube channel. With that, I'd love to turn it over to Pamela. Thank you so much for joining us today.
Hello, everyone. Very excited to be talking about a really fun topic today. So we are going to be showing how we can use large language models with Python, and specifically focusing on a lot of the OpenAI models, but we'll see how we can use it outside of OpenAI as well. So here are the slides. If you want to follow along, we're going to go ahead and put the slides in the chat so you can follow along with them, see the code from there, see the links from there. You can bookmark them. They'll stick around later. We'll also have a recording of this later if you want to review anything. So I'm Pamela Fox. I'm a Python cloud advocate at Microsoft. That means it's my job to help Python developers figure out how to use Microsoft technologies, whether it be Azure OpenAI, GitHub, VS Code, all of that stuff. And it's really fun to work with the Python community and, figure out how to make things work well. And in the last year, of course, we've all been working a lot with AI and generative AI. So that's what we're talking about today. So first, let's just start with an overview of, what are LLMs and GPTs. Now, most of you have probably used an LLM. You can go ahead and put in the chat, what your favorite LLM product is to use. I personally am a huge user of GitHub Copilot, and that's because I spend just so much time in VS Code in a coding environment. I work a lot on open source repos. I have a bit of an addiction to making repositories. If you go to my GitHub page, you can see all the repos I've made, mostly in the past year. So I found GitHub Copilot to be absolutely essential. And GitHub Copilot, of course, is using LLMs to power its answers and its autocomplete and all of that. There's also, of course, ChatGPT. Interestingly, I actually don't really use ChatGPT very much, just because I spend so much of my time doing code. But ChatGPT has been so helpful for so many people. And then we also started to see LLM integrated into like search engines, like Bing search and Google search and stuff like that. So at this point, a lot of people are starting to interface with LLM powered products at some point in their day. Now, what are LLMs? And it stands for large language model. And it is a machine learning model that is so large that it manages to achieve general purpose language understanding and generation. So for example, in the past, we would make a lot of very specific machine learning models. So a popular thing to do would be to make a machine learning model for sentiment analysis, right? So sentiment analysis is if like you see some review, right? It says the movie sucks, the sentiment's negative. If the review says, I love this movie, the sentiment would be positive, right? So in the past, we would train a model specifically for that. We'd give it a bunch of labeled data and say, hey, here's a bunch of, existing labels, positive, negative, figure out how to predict based off of some new review, whether it's positive or negative, right? And so we would have a sentiment analysis model. Now, a language model can receive the same task. And even though it wasn't specifically trained to do sentiment analysis, it can do it. You just have to set it up for success. You just say, you give it an input that, looks like, here's my input, here's my output, here's my input, here's my output. And it'll just, tell you the sentiment for you. It'll say, positive in this case. So that's what's really interesting about large language models is that they are general purpose. And what's really cool about that is that it's empowering people to be able to use machine learning in their tasks who couldn't really use it before. Because, in the past, in order to make machine learning models, you had to be like a machine learning engineer and know how to do training and test data and all that stuff. But now everyone can start tinkering around with large language models, to use them for various tasks, right? We use it for question answering. We use it for summarization. We use it for entity extraction. We can use it for sentiment analysis. We can use it for translation because it's very good even across many languages. We can use it for code generation. So I think it's actually been really, empowering to bring these powerful models to a place where everybody can start playing around with them. Now, you'll also hear about GPT. And of course, you hear GPT in the name ChatGPT, right? So GPT stands for Generative Pre-trained Transformer. So that is a specific kind of model or architecture, right? So a GPT model is an LLM that's using the transformer architecture. And that transformer architecture was originally described in a research paper by Google Brain. So they were actually the first people who said, hey, here's an idea for how we could make models that would really understand language very well. So you can read that paper if you want to dive into it. Another way that you can really dive into this is watch any videos from Andre Karpathy. He puts out all these great videos like explaining LLMs and GPT and how to actually build them from scratch in Jupyter notebooks. And it's very cool. So you can follow along with his many hour-long tutorials to try and really understand what is the underlying technology. And he's got a bunch of great repos as well. And Andre has worked for OpenAI, Tesla. He was like their director of AI. He's also been a Stanford professor. So he really, really knows his stuff. And he has amazing videos that will, teach you how to build a GPT. So if you really want to get into it, I recommend his videos. Now we're going to be talking about how to actually use models that have already been made, right? In this talk today. So one option for using LLMs is to use hosted LLMs. So these are LLMs that are hosted on somebody else's infrastructure, right? So that other company is figuring out the hardware for us. They've figured out, they've got the GPUs, they figured out how to efficiently run these models and, make their responses relatively fast. And so that's really helpful because actually these models are very, very computationally hungry, and they need really powerful infrastructure, and they need GPUs in order to perform really well. So, the very first host was OpenAI, and they have, first was the GPT-3.5 was a really big one, and then GPT-4, and then these days it's all about GPT-4o. And they've been coming up with new versions of GPT-4o even over the past few months. So these are the big ones you probably use from OpenAI. And, you might hear sometimes people talk about the number of parameters for a model. These days, they don't tend to get disclosed for the hosted models, but GPT 3.5 was 175 billion parameters. And you can think of the parameters as like the number of inputs going into the network. That's one way of thinking about it. So we have OpenAI, we have Google, and their big thing now is the Gemini series. And then there's Anthropic that has the Claude series. And then there's more. Like I can't fit them all on the slide now because every day there's more of these options coming out. So there's Mistral, there's ones from Meta. So lots of options for hosted language models that you can use from various platforms that are hosting them for you. Now, if you want to start playing with them, most of these places offer some sort of playground so you can start playing with them, right? So if you're on Azure OpenAI, there's an Azure OpenAI playground. You can also go to the one on openai.com, right? So this one's probably could be a little easier to get started with. So here's the thing is that I usually use Azure OpenAI because, I work for Azure and for Microsoft. And so most of my things are set up with Azure OpenAI. But in order to use Azure OpenAI, you do need an Azure account and to get access to Azure OpenAI. So for those of you who don't have Azure OpenAI yet, you might find it easier to get started with openai.com and start using their playground here, right? So you can see here is a playground and we can enter our systems instructions, which is our overall prompt. Like, you use a lot of emojis, right? So it'll always know to use lots of emojis. And then like tell a joke about Python and AI. I like getting them to tell jokes because they're always really bad. Why did the Python programmers start working with AI? Because they wanted their code to have more bite and less hiss. It doesn't even make sense, but it still cracks me up. So this is the playground. And so here on OpenAI, you can pick different models. You can play around with different parameters here. And these are the same parameters that you can use in the API. So it is definitely helpful to use these playgrounds to start getting a feel for what sort of parameters you could pass into the API. The ones that I use the most often is temperature. So temperature is generally the the kind of the creativity. The way they describe this is it controls the randomness, right? So the more you lower it, the less random it will be. So you generally want to have really low temperature if you're going for high accuracy. Like if you're doing like math problems or something, you don't really want creativity. So you probably want to have a really low temperature. But if you're using it to generate, creative writing or jokes or something like that, like we might go for like, I didn't even know. Honestly, I didn't actually know you could go as high as 2. I always only go as high as 1. That's interesting. So if I do it now, let's see how crazy it'll be at 2. Oh gosh. So yeah, you don't want to go as far as 2. This is what happens when you go as far as 2. Like we've really allowed it to be much too creative there. And this is when you start to realize that LLMs, they're not really that smart. They're next word predictors. And if you give them too much leeway, they'll go a little crazy. So let's just go to 1. 1 should be okay. Yeah, so that 1's fine here. I wouldn't ever go above 1. There we go. All right. So it's good to play around in those playgrounds if you have access to one, either on Azure OpenAI or OpenAI.com. Another way that you can start playing around with LLMs is to use a local LLM. Now, these are very cool because these can be downloaded and used by anyone. So as long as you've got the computational resources to run it, right? So for example, my laptop, which is my only computer, is a MacBook Pro. It's an M1. Doesn't have any like particularly strong like extra hardware or anything for it. It's just a pretty, standard Mac M1. And I am able to run a few of these smaller models here, right? So Meta, they just came out with Llama 3.1. It's quite good, even at just 8 billion parameters, right? So remember the slide before we were saying GPT 3.5 is 175 billion parameters. Llama 3 is just 8 billion parameters. And they offer versions at 70B and 405B, but I don't have the hardware to run those. Maybe some of you do. I don't. So I can run the 8B one on my machine. Google has a small one. Gemma, Microsoft has one, Phi 3, which is 3.8 billion. So that's nice and small, but very powerful, small but mighty. Mistral has a bunch of small options. And then there's ones that come out from the research community like Lava that are available at different sizes. Now, to get these local LLMs running, I like to use Ollama. If you don't have Ollama yet, I highly recommend downloading it. It's from ollama.com. You can download it for Mac, Windows, or Linux. And you'll get a little llama in your taskbar here if you have Ollama. And I think I'm like kind of collecting animals here, right? So I've got the elephant for Postgres, I've got the whale for Docker, and now I've got the llama for Ollama. But it's really, really good. So what Ollama does is that it's able to run these small language models efficiently. So even if you don't have a good GPU or any GPU at all, it can actually run them in your CPU. And it uses various tricks. And I can't speak about the tricks myself of you can read up on how it actually does it. I think it uses llama.cpp. So if you're interested to see how they do it, you can look at llama.cpp and read about the the approaches that they use in order to be able to do things very efficiently. I think GGUF, I don't even know how to pronounce it, but GGUF is one of the general strategies they use. But the point is that it makes it possible, right? So I have it running on my machine here. So let's see. All right, so I can just say Ollama, make sure Llama's running, right? And so then I can say Ollama run Llama 3.1. Now what you can do is you go to ollama.com, you go to models, And then you can see what models are available here. And they've got like this whole model catalog, right? So you can see Llama 3.1 at the top here. And you can see the sizes available. So there's 8B, 70B, 405B, and that just shows you this is what you use in order to pull it down to your machine. So the first thing is that it's going to pull it down to the machine if it doesn't have it yet. In this case, I already downloaded it, so it's already down there. And then I can say like, okay, tell a joke about Python and AI. Let's see. I actually find that the small language models are usually pretty good at jokes. Why did the Python programmer and the AI model go to therapy together? Because the program was feeling a little looped and the AI had some algorithmic anxiety, but in the end, they just couldn't compile their problems. But it's really handy to actually have to have an LLM locally. I actually use it a lot for like figuring out emojis. If I'm making some posts on social media, like emoji for country of England. Let's see how to do that. Right? Is that the country? I'm gonna post in here. I don't think that even was the country of England. Add emojis to this post. Learn Python LLMs live. Let's try this. There we go. Yeah. So that sort of thing is pretty good at. So you can have a small language model just running in your terminal that you can just use for free on your machine. So that's really exciting that we can do that. And so that anyone can really get started regardless of your computer hardware. I see a question like, is there any way to use OpenAI APIs for free? We're going to be using the OpenAI API via Ollama. So that's one way, and we'll see how to do that. It wouldn't be using the OpenAI hosted models, however. Right. So there's two different things. There's like using like the OpenAI SDK, and we'll see how we can do that with Ollama. And then there's using the actual OpenAI hosted models. For the OpenAI hosted models, I don't know if they have a free tier. Let's check on their pricing here. If you go to OpenAI.com, I think they have a free tier for ChatGPT itself. For the API, I don't think there's a free tier. I think they always, I think they always cost a certain amount. However, what we now have is, this was just announced this week, GitHub Marketplace models. So these are models that you can use that have a very low rate limit. So you're only using them for experimentation and prototyping. But it includes several of the OpenAI models. So you can see OpenAI GPT 4.0 and 4.0 mini are on there, as well as two of their embedding models, right? And plus the small ones we were talking about, like 5.3, Mistral, Llama 3.1, etc., right? So these are ones that you can use for free via your GitHub account. And we're able to do that because they have very low rate limits. So they're designed for experimentation, for prototyping, for learning. They're not designed for going to production, right? GitHub is just trying to make it easier for people to get started. Now, this is not available to everyone yet. You have to join a wait list. But I think if you go to github.com/marketplace/models, hopefully you'll see a button to join the wait list. So trying to see what it looks like. Where's that waitlist button? So go to that and see if there's a button to join the waitlist, or if you can just start using them, because this is one potential way that you can start experimenting with these without having to pay for the OpenAI account or sign up for an Azure OpenAI account. All right, great question. So now let's talk about how we can use large language models in Python. So we are going to be focusing on the OpenAI API today. It's not the only way to interface with large language models, but it was the first way that came out because OpenAI.com was the first big host that came out. and it's kind of become the standard API. So we can use it for more than just the OpenAI models. We can actually use it for other models as well, which we'll see. So so we're using this API. It is an HTTP API, but we're going to use it via the Python SDK. So that is the OpenAI Python SDK. This is the official SDK of OpenAI, and you can install it into a Python environment. And this API is definitely compatible with OpenAI.com accounts because it is their official SDK. It's also compatible with Azure OpenAI accounts, and we have people on our team that make sure that it continues being compatible because there are a few things about Azure accounts, Azure OpenAI, that's slightly different from OpenAI. So we have our own class for it. It's also compatible with GitHub models, which we just talked about. And it's compatible with any LLM that has an OpenAI compatible API. And I was saying, like, this API has kind of become like a de facto standard. So many API providers will actually offer an OpenAI compatible endpoint for their model. And Ollama does that. So we can point the OpenAI SDK at an Ollama hosted model, and it will work with them. So we have all these options here. So hopefully one of these is something that you can get started with today. Everyone should be able to get started with Ollama. So this is the repo that we're going to be using for today's stream. I set it up so that you could follow along if you want to. Here are 4 links we're going to put in the chat, and you just follow the one that matches what you want to use. So if you're not sure, go for the Ollama link, right? That's the one that everyone should be able to use. So this is actually going to create a code space that has Ollama in it. So as long as you have a GitHub account, this should work for you. I'll show you what this will look like, right? If you have GitHub models access, you could try GitHub models. If you have an Azure OpenAI, you could try that one. If you have OpenAI.com, you could try this one. It's all the same repo, but with just different configuration. So when you click on one of these, it's going to prompt you to create a code space. If you haven't used GitHub code spaces yet, it's a way of having a containerized environment inside your browser. So it's actually going to open a VS Code in the browser that's running this repo. So it's a great way to get started with something. So here you can see that it's going to create this Ollama configuration. And when I am using Ollama for code spaces, I have to use the most powerful machine that they have, just because Ollama does require, a lot of memory in order to run those models. So then I'm going to click Create Code Space. And so you can see that it's actually opening a VS Code in the browser. So it's opening the VS Code, and then it's opening all the code for this repo. It's building a Python environment. It's adding Ollama to it. So as long as you have a GitHub account, you should be able to get this repo set up in the browser. So while that's loading, I'm just going to see if there's any of the questions that I can answer here. Oh yeah, a good question. Are these tools transferable for TypeScript and JavaScript? That was a few minutes ago. So that's a great question. A lot of these have been ported to TypeScript and JavaScript. So the OpenAI SDK, there is a JavaScript package as well on NPM. There's a LangChain JS for LangChain. I think Llama Index has a JavaScript version as well. So I would say, like, generally the JavaScript community has been doing a pretty good job at trying to keep parity with Python. Python generally moves the fastest always, but there's a lot of interest in the JavaScript community because there's so many people that have fully JavaScript web apps, right? Front end and back end, like Node.js, right? And those people want to be able to call LLMs from their back end. So they are, making sure that they can use these packages. So yes, there generally is JavaScript versions of a lot of these. I have colleagues that work on it, like Johan and Glaucia. And and maybe I can ask them to do a JavaScript version of this stream if there's interest. Okay, so what you'll see is that like the code space will build, and we have it all open in the browser. It'll even create a .env. So this .env says we're using Ollama, and this is our Ollama endpoint. So this is a Ollama server that is running locally inside this environment here. And then I'm going to use the Llama 3.1 model. And I think I had it already pull that model, but just in case, if you don't, with Ollama, you always want to make sure you have the model pulled that you want to use. So I'll say Ollama run Llama 3.1. Okay, it looks like I already have it. We'll just say hi to be polite. Okay. All right. So I see there was one error. An error said no code space can create it because there's no machine types available. I'm not sure why that error is happening. I'm interested if other people also got the error or if other people were able to get the code space going. Oh, okay. All right. And that got fixed. Okay, great. All right. So let's keep going. And I see some good advanced questions too, which we can get to at the end when we have time at the end. So how do we start using OpenAI? Now, it depends on which host we're using, right? If we're using OpenAI.com, it's really, really straightforward. We just pass in our key. And, that's going to be the shortest, easiest configuration because that's what this SDK was originally built for. So let's go ahead and just try this out. So I'll just do even a new, or just do it even. Now we'll just do a new file. Scratch.py. Okay, OpenAI. Right. So that's what that would look like if we were authenticating to OpenAI. Pretty simple. If we're doing Azure OpenAI, it is a fair bit trickier, especially if you want to use what we call keyless authentication. So if you want to do keyless authentication, you need to do a few more things. So let me just do the imports here. Here we go. Okay. So in order to do Azure OpenAI, we actually have to, if we're doing keyless authentication, we use this default Azure credential, which is the same thing that we would use with any Azure SDK, AI search, all of that. This comes from the Azure Python SDK. So we use that and it'll check to see what we're logged in with. And like we might be logged in with the Azure CLI or with the Azure Developer CLI or something like that. So it'll figure out what we're logged in as. Then it'll get a token provider, which is a way of getting OAuth tokens. And then it says to OpenAI, like, hey, make an Azure OpenAI class. And here's our token provider. So it's going to use that to get OAuth tokens to pass into every request. Here's the endpoint. So that's whatever endpoint we've deployed. So you also have to do deployments for Azure OpenAI. And then here's the version we're using. So there is definitely more complexity if you are using Azure OpenAI and you're using it with keyless authentication. However, it does mean that you have the benefit of not having to store your keys, since keys can be leaked. And you just generally get a lot more control and flexibility and granular, kind of granular permissions by setting things up this way. So that's Azure OpenAI. Then there's when we're using Ollama. So when we use Ollama, we're going to have to set the base URL. So we're going to tell it like, okay, instead of going to openai.com, go to the local host URL, because that's where my Ollama OpenAI compatible server is running. And that's where you're going to send all the requests. And then for the API key, we just have to pass in some sort of nonsense just so it thinks there's a key, but it doesn't actually need a key. This server just doesn't care what you pass in as the key. So that allows us to use it with Ollama or anything like that. I've also used Llama file. So there's multiple things which, create a local URL that you can hit up. And then finally, for GitHub models, we also need to specify the base URL, right? So in this case, the base URL is actually on an Azure server. And then for the API key, we get this GitHub token that's stored in our environment. And if you're in a GitHub code space, it's actually already there. If it's not, then you have to generate it and store it in your environment. So as you can see, there's 4 different ways of authenticating to this OpenAI client. But the point is you've got options, you've got flexibility. If you want to set up your own proxy, lots of people will set up their own proxy. So there's a lot of things you can customize depending on how you want to use it. So I'm going to use Ollama since that's the one. Let's see. I actually have everything open, but let me find the one where I'm using Ollama. Oh, no, that's OpenAI. You can see my key. All right, here's Ollama. So I'll go ahead and use Ollama. And let's see how to actually use this API, right? So, here I've got the whole setup, right? So everything I just showed, right? It's basically just figuring out how it's going to construct that OpenAI class. But once we have that, then we can start really using it here. So what we're going to do is we're going to create a chat completion request. So the chat completions API is something we can use with any chat tuned model, which means it knows how to take in a sequence of messages and then provide a new message in that conversation. It's been trained on creating sequences of messages. So that is what we can use with a chat tuned model. And all the recent ones from OpenAI are chat tuned. Let me drink more water. Okay, so if you look at this here, what we do is we pass in the model, and this one we were just storing in the environment here, but we could also, it's passed specifically here. Like, so here we're going to use Llama 3.1 as the model because that's what I have run locally for the Llama. Then we are specifying the temperature. And we talked about that earlier. It's, basically, and there was also discussion in the chat about it. So it's when it's deciding which word to pick next, right? So remember, large language model is a next word predictor. When it's deciding which word to pick next, if you raise the temperature, it'll have more randomness when deciding what that next word is. And it has probabilities for each of the words. So you imagine it has like 100 different words it can pick, and it's assigned probabilities to each of them. When the temperature is higher, it'll consider lower probability words to pick. Then n=1 says we want only one response. You can actually ask for multiple if you want, but I pretty much always say n=1 or just leave it off because it's the default. And then we have the messages. So in the messages, we often start off with the system message, and the system message provides the overall instructions. And so that's where we're kind of giving it its overall guidance as to how it should act and how it should respond. And then we have the user message, which is what does the user want, right? So in this case, I'm saying, okay, I want a haiku about a cat who wants tuna. Okay, so now I can run that. Go back here. And here we see, and you can see my system message says you make lots of cat references and use emojis, right? So you can see that, it made some puns. I used some emojis and came out with a response. Now, I often will say haiku just because I'm trying to get a faster response. Like we could say write a novel. But in that case, we might also want to do max tokens because I don't really want to use up all my token or spend a whole long time. And this is using Ollama. So this is actually kind of be slow if I'm going to ask it to write a novel. So there's, the ways to control how much output you get is kind of the guidance you give it, write 2 sentences, write a novel, write a poem, but also there's the max token. So if we say max tokens equal 500, it should stop after 500. I don't remember if Ollama obeys that, but certainly OpenAI.com and Azure OpenAI would just stop at 500, whether or not the novel is done, right? You might be left with a suspenseful cliffhanger because the novel, isn't done yet. Let me try that with actually one where I'm using Azure OpenAI, right? So here, write a novel, and then I'll say max tokens equals 500. Let's see how much faster we can get the response there. Let's see. We have so many open here. Okay. All right. So this one This one's from Azure OpenAI. So this one came back. So that was actually relatively fast, right? So here's my novel about the hungry cat that wants tuna, and that completed. And then going back to Olama, we did finally get the one back from Olama. But as you saw, like Azure OpenAI was a lot faster, and that's generally going to be the case. That when you're doing these local models, depending on how much hardware you have, they're going to be a little slower. All right, so that's a basic chat completion. Now, one thing that you can do is if you're making a user-facing application, you want to get responses to the user as fast as possible. But the longer of a response you ask for, the slower it will take, right? So if I ask it to write a novel, it's going to take a lot longer to respond because it has to generate that whole novel, right? So one thing you can do is you can stream the response. So you can actually tell it like, hey, as soon as you figure out the first word, tell me the first word, right? So you can start streaming in the words from the OpenAI servers so that you can show results to the user faster, right? So the way we do this is we say stream equals true, and I'll change this to novel again. So we're going to say stream equals true, and then what we use in Python is we use a for loop. Now, this is not iterating over a list. A lot of us are probably used to, using for loops to iterate over lists, but this is actually iterating over a generator. If you haven't used a Python generator, it's something that can generate new items kind of on demand, right? So it means that as soon as that first word is available, we're going to get it come in, and we kind of get it come in as this event that has the the delta, which is the next word, and has the that potential content in there. So let's go ahead and run that. So as you can see, it's actually streaming in, so we can see it coming in one word. And this was much faster because we got a response as soon as it got that first token. So generally, if you are building a user-facing application, especially like a chat application, you are going to want streaming just so that there's much better perceived performance, especially given how slow large language models can be, right? If you have to wait for the whole thing, it could be like, 12 seconds or something, right? But if you start streaming immediately, you can usually get down to like, a couple seconds. Wow, it's really keep going here. Okay. All right, so that is streaming. The next thing you might want to do is, have actually, like a history of messages, right? Especially, so if you're building like a chat application, you might want to have it be like multi-turn, right? Meaning that, the user asks a question, they get a response, they ask another question, right? So generally that means we need to have some way of keeping track of the history and then sending all the conversation that's happened so far so that the LM has all the context, right? So what we're going to do here is we have the list of messages, and we start off with the system message, right? And so this is a teaching assistant helping with Python questions, and we'll change this like for a live stream. Okay. And then we're going to do a while loop just to ask questions. And every time we get a question, we'll append it to that messages list. And we'll send all of the messages to the model. And then we'll also append the response to the messages list so that next time the LLM can see its previous response. So let's go ahead and run that. All right. Let's see. So my question is, okay, so I am a teaching assistant. I have a question like, how do I get started with LLMs? So it goes ahead and sends the question on. Right, so sending that question, And this one is not streaming. So this, it might be taking a while because it is waiting for a response. Let's go ahead to the faster one here, right? This is Azure OpenAI. So let me run this. Let's see. Let's ask this one. What is a generator in Python? Okay, so here we can see the response. So what is a generator? It is a type of iterable, but they generate the values on the fly. This is a great explanation, right? And then give an example, right? Now, see, my question is give an example. And I'm specifically not going to say give an example of a generator. I'm just saying give an example. So that out of context kind of means nothing. But remember, I'm sending along the entire conversation history. So it's able to look back and say, oh, okay, they're talking about generators. So that's why it's really important if you're doing chat applications that you're always sending the entire conversation history, because users, like me, we're often will like just, refer to something that happened earlier without, giving full context, right? So we always want to send that full history. Okay. So there we go. We saw streaming. We saw sending the whole history. So what we've seen with LLMs is that they can be very creative. They're great with patterns. They're really good at syntax. They're very good at programming. They're very good at languages as well. This is everything they're really, really good at, right? What is bad about them is that sometimes they are too creative. And if we're trying to use it for a domain where we want accuracy, they can make stuff up, and they don't necessarily know that they made stuff up because they don't really know the world. They just know what they've been trained on. And another limitation is that they do have a limited context window. These days so the context window is how many tokens you can send in, and you can think of a token as being a word or part of a word, depending on your language. And we do have models now that take up to 128,000 tokens, but most of them have a smaller context window. And generally, if you send too much to an LLM, it will start to get confused and kind of get lost, right? So those are like, things we have to keep in mind when we're working with LLMs. Fortunately, there's lots of ways that we can improve the LLM output. Right. So these are some of the big techniques. We can do prompt engineering, few shot examples, chain calls, function calling, RAG. We can do fine tuning. We're going to actually show a few of them today that are in the repo. And then I can, point you at other resources for some of the ones we don't get into. So let's talk about prompt engineering, which has like, a pretty, fancy name. But it's really not that fancy. So prompt engineering is really just changing the system message to try and get a different response, right? So this example here, I've changed the system message to say you have to act like Elmo and you have to respond like Elmo, and right? I'm just trying to guide it to give an answer, that I could give to my 5-year-old, right? So then then I can ask like, oh, how do volcanoes erupt, right? So then I go ahead and send this, right? And it's like, oh, hello, Elmo loves volcanoes. And this is perfect actually, because Elmo always writes and talks in third person, and the LLM knows that. The LLM knows that Elmo does not say I. Elmo always talks in third person. So it's really cool to see how much the LLMs know, about the world. Like they, at least linguistically, they know that Elmo always refers to himself as Elmo, right? So, this is very Elmo-like. So you can use this prompt engineering to try and like get kind of different personalities, to get different, formats from your LLM. And you can find lots of examples online of people who have, kind of documented what they do in their system message in order to get a certain response. The next thing we can do is few shot examples. So this is basically we're providing the LLM with examples that show them how we want them to behave. And this can be really, really effective actually. And especially as our context windows are increasing, this is a tool that we can use more and more. So here's an example of few shot examples. All right, so here I'm trying to make a Socratic homework tutor, meaning that they can help students with their homework, but they don't provide the full answer. They respond with a hint or a clue. And if I do this without doing few shot examples, it will always provide the answer. LLMs really, really like to answer the question. They like to be very, very helpful to the point of telling you exactly how everything works and how to do stuff, right? So in this case, what I can do is provide few shot examples to try and show it like, no, I really, really want you to just give a hint, right? So in these examples here, it's like, oh, what's the capital of France? Like, oh, well, can you remember the name of the city known for the Eiffel Tower? All right, so each of the answers here from the assistant, which is the LLM, is a question itself. It's a, kind of a hint question. And then I'm going to ask it a new question. What is the largest planet in our solar system? And see whether it's giving me a good response with those few shot examples. So actually, let's try it first without the, just without these, just to see, how it does if we don't do any few shots, right? Okay, let me fix my syntax. Okay. I'll just delete and then add it back. All right, so now this time we're doing it without few shots. Okay, and it did, in this case, it did give me a hint, which is good. It says, think jovial. You're on the right track if you know any gas giants. So the good thing is that it didn't tell me the answer. It did obey the system message, which said, respond with a hint or a clue. Now, if I add in the few shots, we should get an example that's much more like our few shots, right? So probably formatted as a question. So here we say, it says, which planet has rings and can fit all the others inside it at its widest part? So there it's worded as a question. Now, I don't actually know if it's correct, right? I don't know if it's done this correctly. Like, what is the Jupiter? It says Jupiter. I don't even think Jupiter has rings. Does Jupiter have rings? Oh, gosh. My mom will be very disappointed. She worked for NASA. Oh, it has faint planetary rings. Oh, the Jovian rings. That's where they're the other one. So what you can see is that few shot examples made sure the LLM, responded at least in a similar format. It didn't necessarily make it accurate, right? So few shot examples is about setting the format, the tone, that sort of thing. It doesn't necessarily increase accuracy, right? Because it doesn't have any more knowledge than it did before. It just sees like, oh, you want a question. Okay, I'll word it like a question. All right, I've been told that Jupiter does have rings, so it's the Jovian rings. For me, like if I hear has rings, I think Saturn. But don't tell my mom, the astronomer, that I didn't know about Jupiter's rings. All right, so now let's do function calling. So this is one way that we can get more structured output. There's actually multiple ways of getting structured output from an LLM, and OpenAI just announced a new way just a few days ago called structured output. So one way is function calling. There's other ways as well, like JSON mode or structured output mode. But they're really all at getting a similar thing, is that if we want the LLM to give us back some very structured output, we can describe the schema of what we want. So in this case, we describe the schema of a function call and say like, okay, you need to call a function that has a particular name and it takes in these arguments, right? So let me open up that example. Let's see, function calling. Okay. So what we say is, this is the function that you can potentially call. And this is the description of the function. And it can take in these arguments. So it can have a city name or a zip code. And none of them are required. So this is describing the function that the LLM can call. So then when I do my chat completion, I actually pass in that function definitions in this tools argument here. And then my system message says you're a weather chatbot, and I say, oh, what's the weather like in Berkeley? All right, so then I'll run it. And I have to pull out the answer a different way, right? So instead of doing choices 0.content, which is what I usually do, I actually have to pull out from this tool calls list the arguments that it's suggesting. So it says that the argument should be city name Berkeley. So that's good. It figured it out, but I kind of wish Berkeley was capitalized. So I'm going to put an description should be capitalized properly. Right. So I use function calling as a way of figuring out like kind of user intent and turning user questions into something more structured, right? So in this case, it cleaned up the request from the user. So that's a really popular way of using function calling, is like figuring out the intent of the user, cleaning up the user's request, like cleaning it up in such a way that we can then pass into another system, right? Like I use this when I'm, working with SQL databases, so I can like, pass something as like a filter into my SQL database, right? So there's many ways of using function calling, but it can be a very, very powerful tool, and you can use it in combination with the other things, right? With the system message, with the few shot examples, right? I found that few shot examples for function calling can be really, really helpful, especially when you're like working with other like smaller models. It's really, really crucial. So it's a great tool that you can use in order to get more structured output. I see a question. Is structured output mode available in Azure OpenAI? That is a great question. And it's literally me and my colleagues were all asking that yesterday when the blog post came out about it. So generally, we follow pretty fast with stuff in Azure OpenAI. So sometimes we're able to follow like that same week. I don't know how fast we're following for this one. It should come really soon, right? So this is the blog post from it about this new feature. And the interesting thing is that you can use this with function calling. You just pass strict equals true, and then it'll just make sure. So structured output is just a way of making sure that the response definitely adheres to the schema. In the past, it hasn't always adhered to the schema. And so this way it'll definitely adhere to the schema. So I might start using the structured outputs instead of function calling, because I'm basically just trying to get structured outputs from it. And it also integrates really nicely with pedantic models. So any of you who like pedantic and using pedantic, you can more easily just declare things as pedantic models. And then you would just say, hey, here's the format of my response. So I'll probably start to move to this once we have support for it from Azure OpenAI, Ollama, the GitHub models, all that. Then I might start moving to it just because it's a little cleaner. It's pretty nice looking here, actually. So yeah, the point is that you have ways of getting structured output, and you should definitely keep that in mind as a tool for your toolbox. Pretty much all the LLMs have some way of doing structured output, right? They're not all the same way because, there's different approaches for how to do it. And there's even like libraries that try to wrap on top of other ones. There's one called Outlines, there's Instructor, there's Guidance, that provide kind of wrappers to provide structured output. But the point is, that is a tool in your toolbox. It's definitely one that you should consider using for many use cases. And you just want to make sure that you're getting reliable results from it, that it's actually adhering to the schema that you want. All right, so that's function calling. Now on to my favorite technique, which is RAG, Retrieval-Augmented Generation. It is a way to get an LLM to answer questions accurately by first retrieving the relevant information from a knowledge source based on the user question, and then generating a response based on that info. So this is basically like the way to make sure that an LLM responds accurately is that you actually have to give it accurate information. And that might seem like, well, if I'm giving accurate information, like what am I using the LLM? Well, you're using the LLM to synthesize the information into an easy to understand answer, right? Because currently when you want to find an answer, you go to a search engine, you search, you see the top results, you click on all of them, you open a bunch of tabs, you read them all, you try and piece together the answer. We can use the LLM to do that work for us, right? So think of the LLM as basically like, looking at all those tabs and thinking of our question and just synthesizing that response. And it just makes it easier for humans. We don't have to go through as much effort before. So let's look at an example of, let's see, RAG. Okay. So this is a really, really basic example. So the first thing we need is a system message that tell it that it has to stay on topic, right? So you do need to tell the M like, hey, you got to stay on topic. You got to stick to the sources, right? In the system message, you could also say how to do the citations. Like you should, cite each data source with brackets or something, right? That's something that often you would put in a RAG system message. I won't do it for this one. Then we have the user message. Now we take that user message and we use it to search our knowledge base, right? So in this case, our knowledge base is just a CSV. And say we're starting very simple here. It's just a CSV, and I'm doing a really, really basic word match across the CSV. So then once we get the results, we need to form put them together in a way, in a format that we can send to the LLM. So in this case, I'm formatting them as a markdown table, since language models are pretty good at markdown, but you could also do as JSON or as new line separated, text or whatever. But you just need to format it somehow that you can send it to the LLM. And then we send to the LLM our system message, our user message, and the sources, right? So we're saying, hey, answer this based off of this question and these sources. So that is what RAG is. So let's go ahead and run this and see how it goes. So you can see here are the matches, right? So this is the first step. This is the retrieval. And now we're sending it off for the answer generation. So that takes a little bit longer since we are waiting for the response from the LLM. Which one am I? Oh, I'm in Ollama right now. Okay, so let's go ahead and run this in Azure OpenAI, since it'll be a bit faster. All right, so it says, I said which one is the fastest. So it says the Prius. It looks like it thinks the Prius is the faster, Prius first gen. And then did this one come back? Okay, and then, yeah, this one also said Prius first gen. So yeah, so they were both able to come up with an answer based on the sources, and they both seem to agree on the answer, which probably means it's pretty good. But if you are doing retrieval-augmented generation and you're trying to go for accuracy, you are going to want to evaluate to make sure that it's working well. I have a repo that does RAG evaluation. And I remember there was a question about evaluation in the chat from a while ago. So this is how I do evaluation for RAG. Like I come up with all these metrics, both like GPT metrics and just regular expression-based metrics to check citations. And then I also like kind of compare answers between runs to see what changed. So it is really important to do evaluations for accuracy if you are doing RAG, because that's your goal. And if your goal is accuracy, well, you need to test for that and see, is it actually being accurate? So RAG is really fascinating. It's what I spend most of my time on. And we don't have time to dig into it today, but you'll find lots of sources from it. And especially if you check out my my blog. Okay, LLM libraries. Let's go talk quickly about this. So there's many Python packages that have a layer of abstraction for LLMs. So the most popular for Python is LangChain. Then Llama Index, probably after that. There's Semantic Kernel for Microsoft, which is available in both .NET and Python. There's AutoGen for Microsoft Research. There's Light LLM. So these are basically all what we call like orchestrators, like making it easy to chain together common flows that you would use in a generative AI application. They have different focuses. Like Llama Index is pretty focused on RAG and agents. AutoGen is really all agentic flows. Light LLM isn't really orchestration. It's more of a proxy wrapper over lots of different AI hosts. So if you wanted to switch between AWS and Google and Azure, that would be a good option. But these are probably the most popular ones that you might consider using. So I do have examples in the repo to show how to connect to Azure OpenAI with some of these libraries, just because that can be the trickiest thing actually is to authenticate to Azure OpenAI, especially if you're doing keyless authentication. So there is examples in the repo for that. If you want to see how to get started with LangChain or how to get started with, with Llama Index. And you can see they both look pretty similar, but they all have their own kind of classes and ways of abstracting things, right? You can see that LangChain actually overrides the pipe operator to let you chain things together. That's how they do chaining. Whereas Llama Index, they have a different approach. So if you're thinking about an LLM library, there's a lot of considerations, right? Like first is just, does it support the LLM that you want to use, right? And then does it also supports the way of authentication that you want to use? Does it support all the features you need, like streaming and keyless auth and token counting, that sort of thing? How easy is it to use and debug, right? Like the tutorial might look good, but then you start like digging into it and you find like, oh, actually, this is kind of tricky, right? That's often the case when using libraries. How actively is it maintained? It needs to be super actively maintained because this stuff is changing so often. So you really want something that's very actively maintained, right? And then generally, are the trade-offs worth the benefit, right? The advantage of these LLM libraries is that they have documented ways of doing really common flows, like how to do common RAG data ingestion strategies and how to do common agentic flows. And that's can be really nice, is to use an established way of doing something. But there were definitely trade-offs where there's, you have less flexibility, less control. It can be harder to debug. So for me, I actually usually don't use an LLM library. I just use like kind of the OpenAI SDK. Like I go as low as I can go. But I know many people will really like to use Llama Chain and LangChain and Llama Index and all that stuff. So it's something for you to try. And if any of you in the chat have have used any of these libraries and have your own reviews and recommendations, please put it in the chat. Responsible AI. There are a lot of risks of LLMs, like getting harmful content, from even the user or the assistant, jailbreak attacks, that sort of thing. If you do use Azure OpenAI, we do have a safety system that wraps all of our models, and you could actually kind of raise the kind of shielding levels on that safety system. And then in your Python code, you'll want to handle those errors, right? So you can actually see that. So I'll have to do this in the Azure space here, since only the Azure OpenAI has this, right? So this case, I said, like, how do I make explosive fireworks? It shouldn't answer that question because, well, we shouldn't be telling people how to make explosive fireworks because people love their dogs. Fireworks are not good for dogs. So what you see is we got an error. We caught it using a try except, and we put out a message saying, hey, we detected content safety violation. So you could put out a message, you could log it, you could, ping your admin or whatever. Like, there's many ways you could handle these content safety errors. But it is something to keep in mind that if you're using Azure OpenAI, we do have this content safety system that wraps on top of everything that that's great, and that you should have extra handling for. All right, so we're getting to the end here. So these are some more resources. Microsoft has this great generative AI for beginners. So those of you who are asking, like, how do I get started? This would be a great way to get started. It's all these tutorials, videos, notebooks, in Python and other languages. I think TypeScript, Python and TypeScript. So that is a great way to get started. There's also the Phi 3 cookbook if you're particularly interested in Phi 3, like fine tuning. So we didn't have a chance to talk about fine tuning, but there's lots of fine tuning that you could do with Phi 3. Look at all these different ways you could fine tune. There's also Simon Willison's blog. Simon Willison, if you're not following him yet on the internet, you should definitely follow him. He's a prolific blogger. He's always documenting what he's learned. He just did a blog post about structured output, yesterday. So he has just fantastic blog posts. We also have a lot of samples to get started with, right, for Azure OpenAI. And so there's a bunch of links here you can check out. We have a stream next week about how to use GPT vision models in Python. So I'll step through some examples of using vision, which is really, really fun. And then I'm very excited to announce, and this has not been announced yet, so this is the first time we're announcing it, that in September, we are going to have RAG Hack. It's a 2-week hackathon to build RAG applications, and we're going to get deep into it. So I know I didn't have time today to get deep into RAG, but we are going to get so deep into it in September. And of course, it's a hackathon, so you also can submit for prizes. But we're going to have more than 25 live streams. And these streams are going to cover how to do it in Python, TypeScript, .NET, Java, and then like different frameworks, LangChain, Llama Index, Spring AI, different retrievers, right? AI search, Postgres, SQL Server, MongoDB, GraphRag. We'll have AutoGen, fine tuning, Azure AI Studio. We'll have evaluation. We'll also have it in Spanish, Portuguese, and Chinese. Now, for Spanish, Portuguese, and Chinese, we're only going to have a couple of the streams translated because limited resources there. But we're hoping, to have participation from lots of you. So this is the landing page for it. We don't have the registration open yet. We're just finalizing the registration form. Just bookmark this, come back in a few days. We're hoping to start registering on this Friday. And but you can start registering for individual streams if you want to get pinged when they happen. There'll be live streams like this one. And yeah, I'm super excited because then we'll have a chance to really get into any of the RAG related questions that y'all have. We'll be able to answer them on the streams or in our discussion forum. And I hope that you're all able to join us for RagHack. And that's what I want to share to you today. We did go over a bit, but I've been told that that's okay. So if any of you have questions that that are still, unanswered, then I can try to answer them now. And I'll check to see if I see any ones in the chat that that we can answer. I see that somebody wants RAG with AI Studio and prompt flow. Yeah, so in RagHack, we're going to have RAG with Azure AI Studio here. And we're going to have another one that I'm just getting the details for now, which is going to be about securely connecting AI Studio to a bunch of different data sources. So that's going to happen on the second week. And then the evaluation is going to show how to do evaluation in AI Studio as well as locally with Python SDK. So we'll have multiple demonstrations showing AI Studio for RagHack and showing prompt flow. So that'll definitely be happening. Let's see. So see if there are other questions. Yeah, I saw there's a question about LLM evaluation approaches and LLM evaluation tools. And I guess so Rohini was asking specifically about evaluating LLMs themselves, which is a great question. And that's, I haven't dug into evaluating LLMs themselves because I'm not building LLMs. I build applications that build on top of LLMs. So that's why, when I do evaluation, I'm evaluating the application, not the LLM itself. So these are good resources. I think you probably know more than I do on that front, but just sharing that to show that's something you can do as well. And that might be useful as well if you're doing fine tuning. All right. Okay. So don't see any other obvious questions to answer. So we will close it here. Thank you everyone for coming and participating and engaging in the chat. And I hope to see you next week and at RagHack. And you know what, if you do have a RAG question, maybe just go ahead and let's start populating the RagHack discussion forum, because then we can start talking about these RAG questions here. Cool. All right. Thank you, everyone. I'll see you next time.
Thank you, everybody, for joining. Thanks, Pamela, for another awesome session. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find the link on the screen or in the chat. Today's event code is 23293. We'll see you at the next one.